All right, karibuni sana for the second session of the mentorship sessions held by ACEK Future Leaders. My name is Kenneth Alwora. I will be moderating this session. Karibuni everyone from Future Leaders, karibuni, and to our guests, University of Nairobi 5th year students. I don't know whether you can hear me, but I don't want you to unmute. If you unmute, tutasikia kuku background, your total background. So just stay like that. Hopefully you can hear us. So today's session, we basically want to talk to the UON students about the subfields of civil engineering. And I was able to get a few of my people who decided that they can come and talk to us about which area of civil engineering the young ones are interested in. They're about to give us an overview for the various subfields and the pluses and the minus, the advantages and the disadvantages of these subfields that we talk about in civil engineering. So I don't know if Alfred is here. Alfred, civil engineering class rep.
I'm here.
Ah, good. Karibu sana, Alfred. I think what I can do is just to do a brief introduction, of people who are to speak from our end. And I think we'll start with Mr. Structures. Mr. Structures.
Yes. So do you make me an admin or a host so that I'm able to share content?
Yes. I'm supposed to do that. You know, this, Okay. Just find out if you can share a screen now.
I think it's possible.
It's possible.
So,
there we go.
Yeah, can you see anything now?
Yes, we can.
Yeah,
yes, we can.
Let me see how this is. Okay, I'm Engineer Michael Motito, and I'll be taking you through structural engineering. I know I have a very short time, 15 minutes. So I'm basically going to do my best to discuss what I've seen structural engineering as in the last 9 years of my practice. Thank you, Alura, for giving us this opportunity. Alura was my classmate. Thank you so much. And I'm just going to go right ahead and just start. So my background is civil engineering, Jomo Kenyatta University, and I graduated in 2011. Don't worry, it was not a long time ago. Looks like just the other day, and I'm currently also doing my master's in water resources. I know that looks weird when I'm talking about structural engineering, and I'm doing water resources, but I'll explain later. And I'm also a registered PE, professional civil engineer with EBK, and also a corporate member of AEK. And as I said, I have 9 years of experience in civil and structural engineering field, and I've worked for 3 companies so far. So I started off as Steel Structures Limited, where they mainly deal with structural steelwork of warehouses, go-downs, such. Then went to Howard Humphreys, which is now Atkins, and I worked on reinforced concrete buildings. I also had an opportunity to work in the road sector and also the water sector for a brief time. And now I'm out in Kenya. So that's where I'm practicing currently. So I'll just be going through what structural engineers do. And there are 4 areas I'm looking at. You could be, if you decide to get into this field, student, once you graduate, you could become a consultant or mostly a designer. Here I'm talking about, just taking an architectural building design and fitting a structural system to it. I'm sure you've gone through structural design introduction in the university, and most of those things, you shall apply them. So you basically, as a designer, you spend most of the time in the office, about 2/3 of your time in the office. Then the second item is that you also get to go to site and supervise work that you have designed for. So that's usually a lot or less of the time as a structural engineer. So you basically doing fieldwork investigations, approving construction materials, and doing site inspections during the construction phase. You also need to be a good communicator, not a very good one, but just a good one. Structural engineering, yeah. I know you need this just to coordinate and consult with other members of a project team, because now a project usually has teams. So you have other engineers, mechanical engineers, electrical engineers, plumbing engineers. There are also quantity surveyors who do cost estimates, and also the main guy who is the architect or the project manager. So as you grow into your career, you can also get into management. You could now become a lead structural engineer. You could become a resident engineer of a big project, say something like Britam Tower, or even lead your own engineering firm. Then the key requirements of a structural engineer, of course, that's why you went to the university. I'm sure you had some very strong mathematics and physics background to do engineering. But you also need to be creative in your problem solving skills. And then you have to think things in 3 dimensions. You know how one item fits the other, if it's a column, how it fits the beam. You have to see that in 3D, the dimensions and all that. But that will come as you go along. Then of course, again, communication skills, yeah. And what structures are we talking about? That structural engineering going done this in school. So building structures, houses, the bungalows and the mansionettes, hotels, office buildings, government buildings, and warehouses. You can also support this and power teams on dams, bridges, culverts. And of course, again, you have to think of the materials that are structural, and we have timber, masonry, reinforced concrete, steel, and composites. Composites are where now you come and combine different materials. You'd have concrete and structural steel, or even reinforced concrete can also be considered composites. And from school, I'm sure the lecturers have taken you through structural components. The picture in front of you shows structural components. We've got beams, girders are also beams, columns, floors, foundations. So you have a section view on the left and a plan view on the right. That's how you'll be arranging your structures most of the time like that. Then another key thing as a structural engineer to always remember is the load path. So the load path is how the load is transmitted from top to the foundations. So when you're designing a building, you're starting from the floor all the way down, and the top floors all the way down. So we get the load starts at the floor, goes to the beams, girders, columns, foundation, and then to the soil or bedrock. And then, of course, as a structural engineer, you need to be familiar or to familiarize yourself with loads, gravity loads. These ones are the vertical loads, the dead and imposed loads, and then the lateral loads with the earthquake. Those are the forces, the pulling forces, the compression forces, bending forces, shear forces. These are things you always be dealing in any. So you have to familiarize with those and make them your friend. I'd like to go to the pros and cons. And just before I go to the pros and cons, these are my thoughts. So I hope not to offend anyone with what I say here. And don't be scared by the cons. All you need to know is that once you start, you always get to know, with creativity, you get to know solutions, and it becomes easier with time. And also, I'm discussing this from experience that I've gone through roads and water too. So if I could start with the first advantage I've seen for structural engineering, I think it's easy to begin with after graduation, because most small and big firms have a structural engineering department. Then number two, for those who don't like going a lot and just love office work, see, most of the time is spent in the design office, combined with periodic visits. It's a bit predictable. And then if you want to be an all-rounded civil engineer, you could start, say, with water, roads, or structures. But from my experience, having started the structures first, I found it to be easier. Then number four, jobs are easier to get, especially if you network with potential clients and other senior engineers, firms, and architects, even on your own. Yeah, so then if we go to the cons, if you are the kind of person who likes being at the top of a project, you find that when you are a structural engineer, the architect and project managers are usually your leaders. So the structural engineer area is a whole project compared to road and water engineers who do actually, you can have one leader. Yeah. Sorry, there's some white text there. I'm just gonna leave it on point number two. Again, it's a challenging job. Lives of many people will depend on your calculations. You can't afford to make any mistakes. So you might lead to loss of life and career. So, it's not like if there's a pothole on the road and there is an accident, the road engineer will be held responsible, not as much as a structure that falls in Kariobangi and it was designed by an engineer. So that would be a difficult situation to be in as a structural engineer. You might even be taken to court. So that's something to consider. And number three, it's also time consuming, especially on large projects. I remember when I was working on Britam Tower, I was kept in charge of about 1,000 structural drawings, which you can imagine. So I had to work late in the office and weekends for almost 1.5 years. So that as well could be a bad thing when you're starting, but now after you get used to such challenging work, then you're able to life becomes easier on other projects. And then the final point, because of time, a structural engineer may lack skills such as cost estimation, contract administration, since these are done the project managers and architects. Road and water engineers have to handle all this. So I think that's it for me. Alura, you can tell us whether it's time to pick questions or that will be at the end. Yeah, thank you.
Thank you so much, Engineer Mutitu. I think because of time and the way we structured this session, if the UON students can kindly just note down the questions, then we'll address them right at the end. And if we won't have enough time, from the poster, you can find our email address there. I think all the questions can be addressed there. Yeah, if the ones that we won't have time to address here, they can be sent there, and in due course, I'm sure we'll address all of them. So, whoever has his microphone on, kindly, this is another session. So thank you so much, Engineer Mtitu Michael.
Karibu.
Wise words. I've seen you've grown from the last time that we were fighting with theory of structures. I see now you're actually the theory of structures. So thank you so much.
Okay.
Now,
Okay, karibu.
yeah, let's go to the next presenter. Paul Omlokoli and Nancy Abira, kindly, karibuni, introduce yourselves and tell us what this transportation, highways and road safety is about. Karibuni. Or we start with ladies first, actually. Nancy, please.
Hi guys.
Hello.
I don't know. Can you see me now?
I can see you. We can see you.
Yes, we can see you.
Yes, I am Nancy Abira. I'm more or less a road safety engineer. I work in the field of road safety. This presentation will have it with Polo Lukoe. Polo Lukoe is a transportation engineer, but then I guess he'll introduce himself. So because of that, how the structure works, it's transportation and then more or less road safety. So Paul will go first, though kindly allow me, I will be sharing Paul's screen
Okay.
as he does the presentation.
Okay, no problem.
Okay. Can you guys see?
Yes.
Yes.
Okay.
Okay.
Yeah.
Thank you. My name is Paul Olukoye, as you've heard. I'm a professional engineer, registered with the Engineering Board of Kenya, a corporate member of the AEK, and also a member of Future Leaders. So I'll just be taking you quickly through transportation engineering. Because of time, I'll hopefully have to go through them faster. So basically, transportation engineering is the application of engineering principles in the planning, design, construction, maintenance, and operation of transportation facilities. So all these 5 steps that you see here are usually necessary in each and every infrastructure that is done usually by any form of engineering. But now transportation basically looks at the movement of goods and people, as you know. And you know, it can be through the air, it can be by sea, meaning ships and stuff like that. It can be on the roads, the vehicles as we know them. It can also involve rail transport and actually pipeline. And now with Elon Musk and NASA, you can really say that space is the new frontier when it comes to transportation. So it's very wide. It's multidisciplinary, so it covers a vast area in terms of transportation. Yeah, Abira, you can move to the next slide when you're done with the library. But anyway, so that is transportation engineering, and we work with a lot of the other disciplines, electrical, mechanical. When it comes to railway, there's a lot of dealing with mechanical and electrical, and even in roads, looking at the street lights and things like those. And yeah, we can move to the next slide, Abira. So the competencies, as you know, you'll be graduating with a degree in civil engineering. So that's one of the starting points. Next, you need to have a problem-solving mindset. Generally, this transportation engineering is always looking for solutions, always looking for solutions, and therefore that has to be a mindset every day when you're coming into work, because you'll be called upon to solve be it congestion, be it logistical problems when it comes even to shipping, when it comes to also railway. How do you coordinate the signals and all these trains moving around so that they are able to get to where they're going in time. Then you must also be ready to learn, and just there are always emerging technologies, new things happening, so you need to keep yourself abreast with what's going on in the industry. And also hard work. I know people say that you can work smart, but there's also a place for hard work. Sometimes you'll be called upon to work beyond what you know. So it involves a lot of research and going back to the books and getting to know what is this, how do I solve this thing, what is the new concept that can be learned. Next. So the general skills that are also required in transportation engineering, as Mutitu said, for structures you might not need this, but in transportation engineering you find yourself being the leader, so you'll need to learn a lot of the project management, coordinating different disciplines of engineering, and even looking at going into contracts administration, because now you're supervising the contractors and getting to know all these things to do with the technical aspects, but also the law of the land, because contract administration is basically about ensuring that the things are handled within the laws of the land. There's also a need to learn the costing of projects, and even now appraisal. Appraisal basically looks at monitoring, evaluation, and even checking if there are economic benefits in the projects that you'll be doing. Then also you need, in the course of that, you'll learn how to write reports and even presenting to, they may be clients, they may be your fellow engineers as you submit maybe proposals and theses to seminars. And also you need to learn a lot of teamwork, because engineering works a lot with teams from different disciplines of engineering, and also outside engineering, for example, environmentalists, socioeconomic, economists, and such kind of disciplines. Yeah. Next one. So just a brief on the highway engineering. Highway engineering is still within the larger transportation engineering, but there's someone who will focus on, I believe Dennis will do something to do with the airports. So under highway engineering, you basically look at, you remember the 5 things I told you earlier? Under transportation engineering is mostly about the design aspects, the construction, and even the maintenance. So within these ones, these are the main aspects that you look at. You have to know, to learn how to do the traffic data collection, how to analyze it, and the correct way of forecasting. Then you also need to learn the geometric design aspects, not just the software, but the actual geometric design that is required. You know, the software, I know a lot of you may have known about Civil 3D, but it's not just about Civil 3D, it's about understanding the geometric design so that when you input whatever you're doing, it comes out correctly. As I said, there is the costing and economic appraisal. Then you also need to learn materials investigation and pavement design, knowing what material is required, and even checking on that, because eventually the contractor will tell you that this is the material that is available, so you need to do the checks and balances on that. Then there's the maintenance of highways. A lot of some of you may end up in the road authorities, and they carry a lot of the periodic maintenance on roads and rehabilitation of roads. So you will need to learn how that is undertaken. How do you prioritize which road to be maintained in a given year? So I think the economics have done it twice. Then there's road safety, which Nancy will talk about, and also environmental conditions. Yeah.
Okay.
Next one, there's under still transportation engineering, there's transportation planning. This one I won't, I'll just skip it since the slides will be provided. It's more or less the same as the highways. Sorry, it's more or less within the transportation engineering, but what it entails is more of the planning, functional design, and operations. So it doesn't touch on the hard infrastructure that will actually be made by the other one, the highway engineer. So this one deals a lot with the office work. So looking at the planning aspects, the functional design, and also the operations of these systems. Next one. So lastly, I'll look at the future of transportation engineering. What are the future aspects of this, because that's where you'll be going, and I think it's important that you know about it. There are technologies developing, and this you need to be aware of. Looking at the transportation analysis software, there is a lot of interest in big data. If some of you are people who are concerned about data analytics, there's a lot of big data, since some of the cities and countries have this proper database of inputs for transportation, including population data, road data. Maybe you can find the lanes, how many lanes they have, how many kilometers of road they have. So such things will be needed in the future as the transportation engineering sector moves forward. There's also artificial intelligence. Then looking at the transportation planning systems, you need to look at the intelligent transport systems, which are being adopted in very many urban cities around the world. This is basically coordination of the traffic signal systems, and even ensuring that there's proper traffic management within these metropolises, to ensure that at least there's consistent and smooth traffic flow at the optimum, to ensure just that the goods and the people are moving properly. There's also, in the planning systems, there's also autonomous vehicles, whereby there's a lot of research going into how do you ensure that the vehicles within the system are moving with the same speed or with the same travel characteristics, to ensure that at least there's a smooth flow. So there's a lot of research going on in that, maybe not here in Kenya, but outside of here, there's a lot of that. Then there's a lot of emphasis on road safety, so you need to be aware of that. There's a lot of concern. Maybe you can, if you read globally, there's a lot of talk of Vision Zero, maybe just ensuring that there are no crashes or deaths that occur due to crashes that happen on the road. Then there's sustainable transportation, looking at alternative fuels and other things that Nancy will cover. And lastly, looking at climate resilient infrastructure. You know what has been happening in Kenya with the floods and all these rivers taking away bridges. How do we design infrastructure that actually withstands those hazardous weather aspects that maybe you could not plan for, but how do you ensure that whatever is there can withstand that? So that is my presentation. On the advantages and disadvantages, I'd say advantages, I think, for transportation is the opportunity to build something bigger than yourself, looking at a road and being able to be part of a very big project, you know, talking about maybe 82 kilometers of road over 100 kilometers. Then ours is different. Mutuku, from the time he was my classmate, has never liked traveling. But for some of us, we like traveling. So it's an advantage to work. I think I've traveled all over Kenya due to this work. It's only Mandera County that I've not gone to, and not only in Kenya, the other countries that I've been to just because of this work. Then there's a lot of learning opportunities, I would say, within the workspace, and even the opportunity to lead. As you've been told, in transportation engineering, you can actually end up being the project manager or in charge of such big projects. And also another advantage is that there are always new challenges. When you wake up on site, or even if you're going to the office, there's always a new challenge in transportation engineering. The disadvantages, I'd say, sometimes there are challenging working conditions. Maybe you can go to a site in a very not so friendly climatic region of of Kenya or even the world, and not just climatic. You know, you can be in a war zone and things like that, and it can be a little bit hectic. Then at times you'll find yourself in places where time limit is constraining, so you really need to sacrifice a lot at times, though not all the time. Then, as always, I know engineers usually want to graduate with a high salary, but in the remuneration takes time. It goes with the levels of as you grow in your engineering, as you grow in your experience and training, the more you are trusted with responsibilities. And obviously, the good thing is in engineering, with the more responsibilities comes more remuneration for your services. So yes, that's my presentation. I'll hand over to Nancy.
So I'll take up from where Paul, actually the last thing Paul was talking about the future of transportation. Maybe let me just say to begin that I find working in engineering way easier than studying engineering. Paul, maybe add that as one of the advantages. Truly, the work you do is way more interesting and way easier than the studying you have to do in school. So I think that's all the time for students. That would be a good reason to finish, you see, and so you can begin the interesting part. So actually, personally, my presentation is just maybe 5 slides, maybe just to show you what is the future. Other than just being a transportation engineer or being a highway engineer, what other thing can you explore that maybe also provides job opportunities? So then that's on sustainable transportation. So ideally, as Paul explained, when you talk about sustainable transportation, more or less we talk of more or less mitigating or curtailing the social, environmental, and climate impacts of transportation. We'll talk about maybe towards fuel economy. When I talk about fuel economy, you start thinking of maybe hybrid cars, electric cars, you see, more public transport, such that now we use less fuel. Again, also when you talk of occupancy, now we stop talking of using cars, but then more or less designing public transport to cater for more people. We talk of electrification of transportation systems. Electrification maybe comes to mind more or less SGR. You know, remember how the discussion had been the previous time when people were wondering, are they going to, are actually the SGR trains going to be electric or not? And then now pedal power. Pedal power more or less refers to non-motorized transport. Urbanization talks of, traffic management, traffic congestion. The previous photo that I was just showing, this is a good representation of 1, urbanization, 2, fuel economy, Number 3, occupancy, and also road safety. So when you start thinking of these things, these negative impacts of transportation, you began opening yourself to new job opportunities that you can explore beyond just studying civil engineering in school. So maybe Paul had explained this, so maybe I will not, seems we had the same mind on this. The first thing when you want to now do sustainable transport, of course, the thing we all have here is the BSc in engineering, you see, or rather, hopefully all of us here civil engineers are Laura, so I may not step I may not step on someone's feet. Yes, but the first thing is BSc in civil engineering, but then because it's sustainable transport, it's a new area, it's a fast changing area. We cannot just be comfortable with having a BSc. So in this case, then, it is very much preferred to explore further trainings. And like we always say, still I believe BSc is the most difficult phase. Beyond the BSc, while fine, maybe I still don't have the MSc and the PhD, but they're way easier and they find you in a better position when you best understand where you want to go and the kind of transportation problems you want to solve. So if you want to go into more sustainable transport, maybe I would advise at this point, you start thinking of beyond your BSc, how can you get your MSc? So there are 2 options. You can either finish your BSc, maybe go work somewhere for a few years, try to find your footing, see what you like, you see, and then explore. At the same time, you might just finish your BSc and straight away, if you already know which kind of transportation, sustainable transport you want to explore, you can go straight into your MSc. But further training beyond this BSc is very much preferred when you want to explore sustainable transport. For MSc, there are also very many options. You can do transportation planning, transportation engineering, transportation management, sustainable transport. They all come, I think, in very different clothing, but then it's the same folks inside, you see. Most of the times you'll find yourself tackling the same things. And then beyond that, now you can go to PhD if you want to, or any postgraduate. Why I'm actually insisting on this is because there's a lot of research that is still involved in sustainable transport. And what better way to be on top of it than actually to have the required skill set. And then work opportunities, when you now want to explore sustainable transport, you want to do public transport, you want to do road safety, you want to do vehicle emissions, you see all that. What kind of work opportunities does it provide you with? This morally, I think this also applies to the larger aspect of civil engineering, but then maybe I'll just focus on sustainable transport. Number 1, you can work with government. It's a new uptake. So even currently, you'll find the government is now trying to employ a transport economist. You see, government is trying to employ a road safety specialist or someone with specialty in public transport. So it's still a new area. If you have your skill set, if you're adequate, you have adequate requirements, it puts you in a very good position to tap some of these jobs. The next one is also consultancy. Consultancy still remains one of the biggest employers, actually in engineering, or rather in civil engineering in Kenya. I'm sure from the presenters, they will tell you either, most of the time, someone is either working with a contractor, working with the government, or working for a consultancy firm. At the same time, maybe the 4th one that before non-government is actually research and academia. Research and academia, in the other areas, in the other civil engineering areas, you might find a lot of work has been done. But then sustainable transport, when you explore sustainable transport, it provides you with a good opportunity to actually work in research and academia. Why? Because some of these things, say for example, traffic congestion, it's a new thing for sub-Saharan Africa. You see, not a lot of research has been done to even determine how long it takes, say, from my place of work where I am now to get to Embakasi, you see. So the research opportunities for sustainable transport, it's still very great. And it's a new area someone can tap into. And finally, non-governmental organizations. And most of the times they say sustainable transport is the civil activism of civil engineering. You see, the civil, yes, you understand what I mean. Because
Yes, yes.
there's a lot of non-governmental organizations that still work in sustainable transport. You see, you'll hear of NGOs working in road safety, NGOs working with women in transportation. See, people working with public transport. You see, people may be checking how much pedestrians, the pollution, you see, from the vehicle emissions, the ones that are impacting pedestrians. But then they may not be engineering firms or engineering organizations. So sustainable transport still widens your area to tap into these engineering organizations. And then maybe just to add, Paul also talked about this. What are some of the related skill sets that you'd want to have when you want to explore sustainable transport? Other than maybe your BSc or your MSc or your postgrad in whatever the area you want to explore, having an environmental science certification, diploma, etc. still adds onto your skill set. Why? Because when you talk of environmental factors, we still talk about sustainable transport. Secondly is things related with sociology, anthropology, etc. You see still, like, for example, I think most of the times when I work in road safety, the first question that always comes up is, what is the socio-economic cost of accidents? So you have to get out of your comfort zone of actually doing road safety engineering and trying to check when someone has an accident, how many of his family members have been impacted? You see, how much is this person going to use in hospital? If this person has a fracture, how much money are they going to use through rehabilitation? So in this way, we tap into the sociology sense, while at the same time, you're still an engineer in its truest form, you see. But then you have this skill set that puts you at a higher pedestal than a sociologist who is not an engineer, because now you understand the engineering elements that come with road safety. But on top of it, you also now have the sociology aspect. And number 3 is, of course, project management skills. Project management skills, I think everyone always says this. You see, most of the times we focus too much on the engineering and we forget how to manage our projects, you see. But still, same to how the transportation speakers spoke about and the structural speaker also spoke about, it's still very paramount for us as engineers to go beyond the technical engineering and see how do we manage this project. So then we don't leave it out to someone else who is not an engineer to manage engineering projects. So fine, maybe if you say for a fair playing field, everyone can be a project manager. But it would actually be better if us engineers, we are still the project managers. And Paul explained the contract management. Actually, I think quite adequately. It might not be necessary for me to go beyond that. And lastly, maybe just in the area that I work on, you see, you have to tout your own ship. So as much as I'm talking about the larger transportation, I mean sustainable transportation, personally, I focus a lot on road safety. So road safety, you do your BSc, so after that you can go into transportation engineering, everything Paul was talking about. And now beyond transportation is the sustainable transport. So then beneath sustainable transportation, we have all the facets of sustainable transportation, and one of them is road safety engineering. Again, even below road safety engineering, there's still so many things you can explore as a road safety engineer. You can just do road safety management, where you only deal with crash data, you see, and you deal with how can Kura set up a road safety department, how can the government set up NTSA? The people who actually did that, some of them, the thought process behind it, some of them are actually road safety engineers, but then they focus a lot on road safety management. After that, we have the safer users. Safer users is now the pedestrians, the motorists, motorcyclists. There are people who only focus in even modeling, you see, how when a pedestrian is hit, if a pedestrian is hit at 30 kilometers per hour, what kind of damage will this result in death? Which kind of injury will the person endure? Also at the same time, how can the users be made aware on how to use the road safely? Also, now we have safer roads. So now safer roads is about the engineering. How do you make the infrastructure forgiving? You see, giving a second chance, such that if I make an error on the road, what can you do such that I do not have a fatal or a serious injury? And how do you make the infrastructure safe? And also the safer vehicles. Safer vehicles, though, has a lot to do with mechanical engineering. You see, like how someone will say, I prefer this car vis-a-vis this other car. You see, how the decision were made to move, to move, how do you call that thing? That thing where you put luggage, the Kitambo one, how did you used to call it a lorry? Like, in buses, they used to have that space on top.
A carrier.
Eh?
A carrier, I don't know.
The carrier, yes.
Yeah, that carrier.
Yeah, remember the decision to even move the carrier from the top of, you see the top of the vehicle, the big buses, now to put them below. You see, or even to have airbags. How do you improve? How do you make sure instead of using metal, you're now using plastic to make cars? So all this encompass safer vehicles. Those safer vehicles, I might say, has a lot to do with the mechanical and automotive engineering, other than, and very little to do with the civil engineering. And also finally, post-crash care. So post-crash care also in this area, we tend to work a lot also with the doctors, you see, because even after someone has had an accident, we go an extra mile to actually engineer. If you've had an accident at Point Paul, let's say that place is called Paul, you see, then we make sure there's a hospital at Point Alwara and it's only 5 kilometers away, such that by the time we move you from Paul to Alwara, someone has not died. Or if it's an injury, it has not moved from a slight to serious injury. And you'll be surprised that some of these things actually model with engineering concepts. You see, it is not just a matter of, let's put a hospital here. There's a lot of learning, a lot of expertise, and this civil engineering who later became road safety experts who have to give their input in formulating such kind of infrastructure. I think that's end our presentation with Paul. Thank you.
Thank you very much, competent civil engineers from TeamCon, our friends from the university. When there's traffic on Thika Road, those are the people you talk to. When you're going to the rural area and you're stuck in Gilgil for 16 hours, those are the people you talk to. Mombasa Road during the curfew, you're looking at the curfew, it is 15 minutes to 9, and you're barely at GM, and all you're seeing is cars ahead of you. Why is there traffic? Those are the people you talk to. So asanteni sana transportation engineers from TeamCon. We've learned a lot. Even I personally have learned a lot, and I'm part of this transportation team. So I hope bado hamjachoka. Let's just go to the next one before we take a small break. And before I say something else, I saw someone had lifted his hand to mention something. I just want to say, let's hurry up first with the presentation such that the Q&A session can come a bit later. So if you kituwia radhi, tafadhali, wacha tukimbie na hii presentation, then we see what we can do later. So the first presentation we had was of structures, major presentation. The second one was of transportation. Now we have the third one from our former chair, Engineer Kiunga, Engineer Kennedy Kiunga. I don't know whether you can hear me. Can I unmute you so that you can go on with your water presentation? Just hold on, just hold on. You're not unmuted, you're not unmuted. Just try unmuting from your end, please.
Yeah.
There we go.
So yeah, my name is Kennedy Kiunga. I don't know how things have progressed so far, but yeah. So I was supposed to talk about water engineering, or I'll actually just concentrate on the hydrology bit. So currently, I would say I work at Atkins. Yes, let me start at that. So we are currently looking at sustainable urban drainage systems, which is a new frontier. Has been there in existence, but for now we are trying to incorporate it in our designs and in our projects. So we have come across so many infrastructure projects which require us to think outside the box with regards to our drainage approach. So in terms of hydrology, what we usually are concerned with is the catchment area and the amount of rainfall or amount of peak flows that are generated from a certain development. For instance, if we are supposed to be constructing, say, an apartment block, we know that we will have an impact on what was there previously, because water used to percolate through the ground, and there used to be a ground recharge naturally flowing to the rivers. But at this point, since urbanization is taking place, we are concentrating more on how we're going to mitigate that impact. So in hydrology, you have the urban hydrology bit and you have the rural drainage bit. So for the rural one, it's pretty straightforward. It's all about getting your catchment area. We usually use either the TRL method. For those who are still in campus, you will come to know how we apply it. So we usually get our peak flows. Our peak flows are generated from the TRL method or the modified decisional formula, plus another third model. All these are models that have been generated with time, using historic rainfall data. So what usually happens is we are trying to show or model how rainfall, based on a number of return periods of years, say, if you're looking at pipe culverts, you're looking at 10 years. If you're looking at box culverts, 25 years, return periods. If you're looking at bridges, 50 to 100 years. These return periods are the probability of rainfall occurring, let's say, in a matter of 25 years, within 25 years or within 50 years. That's what we use. So basic formulas for TRL is we use a lot of coefficients for us to actually come up with the peak flows, or Q peak. You can have lag time because you have the soil type is different, you have the vegetation is different. And then so you have your TRL method, then you have your modified decisional formula, which is your basic Q is equal to CIA, 0.278 CIA. So from there you get your Q peak. So from your Q peak flows, you're able to actually now size your structure using Manning's formula, Q is equal to VA. So for the rural areas, you're just concerned with, is the peak flow from, say, your road, or from your road, or from your structure, from your development, is it going to have an impact on the environment? So we just basically ensure that the water goes to the outfalls. The outfalls are usually natural outlets where we just let the water go naturally. So that's a bit about on the rural side. On the urban area, we still use the same concept where since the area is small, the model that you're going to be using is dependent on the area, the extent of your area size. Sometimes you find that your area size might be above 200 kilometers squared, which you need now to put in another method called the soil conservation service method, which also is a bit of a modified TRL method model, but it still gets to your cubic. Then that's what you use to seal size with the capacity of your drain, which you usually say that the Q design, and we usually design for structures at two-thirds capacity full, to just give way for any, because we know, like in our countries, maintenance is always an issue. So you give way for either siltation, or it could be debris, it could be say trees or something. So the same hydrology bit that you use to get your cubic is the same way you'd actually generate for your urban area, urban center structures. So structures vary. The hydrology thing is quite extensive, because you need a few things that you require to input is your rainfall data, which you get 2 year, or you could say, depending on the return period that you require. You also look at your road manuals. So you have 2 years, you could say 2 years, or as far back as 10 years historical data for you to actually come up with your adequate rainfall. So rainfall has a pattern. So unless otherwise some circumstances happen, like right now, which the rain that has actually fallen has not been experienced for the past almost 85 years. So, but in most cases, it's very straightforward to get your rainfall from the Nairobi meteorological stations. And this rainfall is usually 24-hour maximum, yearly, monthly, maximums. And then is also, you also need to get your catchment area, which you get from topographical maps, 1 to 50,000 scale. You need to have them scanned. You need to use Civil 3D to just actually to make it easier for you, instead of using your normal string and ruler and scale thing. So you just have to digitize them. That's what we refer to as digitizing. And then if in the event that you don't have a topographical map, you can have GIS softwares which can help you generate contours. And from the contours generated, you can actually manipulate that in your Civil 3D to come up with a tin or a tin surface of the ground. And from there, you can manipulate and get your watershed feature from there. So that will help you just get your catchment area. So now in the urban areas, we have what we're talking about is sustainable SUDs, sustainable urban drainage systems, where you have quite a lot of things you're trying to input. So you're trying to mitigate the impact you're having on the hard surface or on the existing ground, because we're using hard surfaces. If you can recall, I think that was last year, but there was the first urban or city to almost run dry, or had actually run dry, Cape Town. Basically, there was no water anywhere, and they had to now start resorting to rationing and stuff. And more cities could be going through the same trend in a few years to come. So what sustainable urban drainage systems do is just a strategy to adopt how to reduce the likelihood of pollutants reaching the water courses, and then reducing the reducing runoff by reducing permeable areas. So this is done by using, you can have filter strips or French drains or swales or vegetated ponds or basins, either retention or detention basins. You can also have underground storage. You can also have green roofs, which is things that are coming up, especially in Kenya. Then you also have rainwater harvesting, the usual. So all these systems are aimed at actually helping us not to recharge our groundwater. So now that we have a lot of boreholes which are being dug every now and then, but we need to think about how we're going to recharge our ground facilities. So in short, that's a drainage bit, hydrology bit. If I need to expand on anything else, I think somebody can let me know, because yes, it depends with now what else would they want to know. Yes, thank you.
Thank you so much, Engineer Kennedy Kiunga. Just a short, brief, I don't know how to put it. This guy was not ready with his slides. Then I had not seen his message. But this shows you how engineers can multitask. He presented something very beautiful, and you wouldn't know that he was not...
I'm just from site. I'm actually just from site.
You're actually just from site, and you came and you prepared. So kudos. Thank you very much. And to our students, by the way, we will be sharing all these presentations with you guys. It's not just that we're reading them to you and then we'll keep them. So I'll make sure that they actually get to you. Now, tupande SGR ama twende na ndege, actually twende na ndege. We go straight to Moi International Airport, whereby we have our resident FL member, Mr. Engineer Dennis Mulitia, to talk to us about airport engineering. Mulitia, take it from there.
Okay. Can you hear me?
Yes, we can hear you. Yes. First of all, Tuma location, uko wapi?
Right now, I don't know if you can see, but actually I'm at the Mombasa airport. That's where we're doing the rehabilitation of the runways, both primary and the secondary one. First of all, I'm Dennis Mulitia. I work for ACEK Consortium. 7 years experience in engineering. Basically, I'm from the class of 2013. Started working in the airport since 2014. And yes, since 2014, I've just been basically between Jomo Kenyatta and Moi International Airport. And basically, I have a BSc in civil engineering with a master's in project planning and management. So just like transportation, what I can tell you guys is that basically just like highways in airports, basically it's just a branch of transportation. So what you'll probably need most of the time is your contract administration skills have to be top notch, because there's a lot of FIDIC and basically dealing with a lot of stakeholders, in which case these are the airlines, the concessionaires. This basically are people who have shops in the terminal building, basically duty free, Safaricom, and then you have the DHL. Basically, these are the transporters. And another thing you have to be good at is also cost and appraisal of the project, because the thing with airport projects, they're very dynamic. Things change by the minute, by the second. So what you might be doing today might totally change tomorrow, dependent on very many things, maybe weather, or maybe the other airlines might be changing their operational procedure, which might only need the authority, which is KAA, which is in charge of basically all airports in Kenya. They have to upgrade whatever things they're doing. So let me kindly share my screen. Basically, so as you can see there, the design standards for aviation industry are basically two. There's the International Civil Aviation Organization, which is known as the ICAO, which Kenya is a member part of. And actually, we're very fortunate enough to be the regional headquarter for the ICAO. And there's also the Federal Aviation Administration, which is usually located in the US. Basically, that's just the same way we have metric and imperial. The states like doing things their own way, but both are accepted either way. So other than that, each aerodrome has its own reference code. The intent of the reference codes is to provide a simple method for interrelating the numerous specifications concerning the characteristics of aerodromes, so as to provide basically a series of aerodrome facilities. Basically what they're trying to say, they just like an airport, let's say like Moi International Airport is considered as code 4D. So it comes code number, it's given a code number as you can see there, and then later depending on the wingspan it can handle, and the amount of length of the runway. So basically that's where they get. The code is usually composed of two elements which are related to the aeroplane's performance, characteristics, and dimensions. That's what you can say. And an aerodrome reference code is basically a code number or a letter that are selected for aerodromes for planning purposes and shall be determined in accordance with their characteristics. So before any pilot comes to the airport, basically he has to know what's the code for the airport. Like an A380 is a code F aircraft. So we cannot land a code F aircraft at Moi International Airport, even though it is considered one of the alternates. If an A380, let's say coming from Dubai, is heading to South Africa and they get an emergency, they can be allowed to land. So basically, yeah, that's the aerodrome code. And when it comes to runways and basically airports, the flexibility to accommodate any future expansion of runway infrastructure is the most fundamental to planning and design of airports. Basically, let me just share this with you. So basically this is Jomo Kenyatta International Airport. And this is the terminal building. And this is the runway 0624. And these are taxiways that are supposed to join. So basically in updation, sorry?
Are you supposed to be sharing a screen? Because the screen that is here is still the one for standards and specifications.
Oh, let me do a new share. Sorry.
Yeah,
Yes.
yeah.
Sorry. So now, as you can see, there's the runway 0624, and then there's the terminal building, which is here, and then there's the taxiways, taxiway Golf, Foxtrot, Echo, Kilo, as you can see. So basically, any side on the other side of the terminal building, where you can't see, where basically where all the aircrafts are, is usually known as the air side. And that's where you have the runways, the taxiways, and the aprons. And on the other side of the terminal building, where like the cars are and everything, where basically you get into the terminal building, that's known as the land side. So basically, the factors that determine the seating and the orientation and number of runways, basically, if you're going to have 1 runway, 2 runways, 3 runways, because that's also a question that has been coming up. Why does JKI have 1 runway only? But there's so many things that, so many factors that contribute to you needing 2 runways. And the first one is the numbers. I don't think for now we have the numbers to make us require another runway, because we can easily handle the capacity that we have right now. And the more important factors that affect the orientation and the number of runways is also the weather, in particular the runway and aerodrome usability factor as determined by wind distribution. I don't know if you've noticed, there sometimes the planes can be taking off from one side and landing with the other, and vice versa. So that one is basically just dictated by the wind. So that also dictates the number of runways you can have and the orientation of your runway. Also, another thing is the topography of the aerodrome, basically the site and the surroundings. You don't want to have air runways next to hills and things like that. Preferably, a flat surface is much better. And the type and the amount of aircraft to be served, the aeroplane's performance considerations, the environmental considerations, which this is basically the noise and the carbon emissions. You want to put that very far away from everywhere else. And an example is London Heathrow Airport, whereby after midnight to around 5 a.m., no plane is allowed to take off or land due to noise emissions to the neighboring community. And other than that, I think basically this is now the terminal building. So on this side, this where you can see the aircrafts are parked, basically that's the air side, and then the terminal building, and this is JKI, but a master plan for future development. And then this is the land side here, where you can see like lanes, traffic lanes coming through. And then this is another photo of the green part is the runway 0624 on the JKI side, and the red part are called rapid exit taxiways. This help in evacuation of the planes faster to increase the capacity of planes that can land and take off at any given time. Next one is, as you are aware, JKI was undertaking a design for the second runway, which I happen to be involved in. So basically this is just a master, as a concept we were giving the client, and the location, which was gladly accepted. So, and as you can see, there's a taxiway connecting both runways just to increase the capacity. And the bare land that is here will be used for future development by the authority. And as you can see, they have major plans with their master plan. So basically at the end of the day, this is the greenfield terminal that is supposed to be here, being collected by a rail train that is coming through parallel to the roads. And then this is the terminal after everything, and here is the second runway. So hopefully in the future, once all this has been realized, it's going to be an amazing, actually, airport city, not just an airport. And finally, for the positives of working in airports, first of all, it's very dynamic and interesting, like I told you, because every day there's a different thing that is going on. Every day you have to have, before you start your work, there has to be a what we call a go no go meeting, basically, and ask your advice of the weather, or if you have any VIP movement, basically, is any president coming, is anyone coming, blah blah blah. And then, yeah, that's the first thing. The second thing, in Kenya, it's really growing right now, as not many people have covered it. Yeah, so I assume, or I can advise it somewhere where you just be one of the pioneers in everything that's happening, basically. And the other thing is there's a lot of traveling. There's a lot of traveling. So, and basically it's just international traveling around the world, seeing everything. And once you travel around the world, you don't only see airport engineering, but you get to experience other aspects of engineering, which you actually can now appreciate much better. And the challenges you have in terms of construction, it has to be coordinated through the air traffic control and the contractor and yourself as a consultant, maybe if you're working as a consultant, which sometimes is very hectic and sometimes requires a lot of coordination. And then the other one is there is high levels of safety and security have to be maintained. As you know, in airports, security is paramount because of terrorist attack and things like that, which are usually not acceptable in the areas of work. And then there's the level of risk and stakes are higher, because you can imagine maybe if a worker left a tool on the runway and a case of what happened to the Concorde happens, it's usually much more, like the risks are much higher in terms of even financial and even loss of life as compared maybe to any other place. And then there's also the challenge of working hours. And like airports, maybe if you're doing rehabilitation, most of the work has to be done at night, which is basically unsociable hours. Maybe you're working from 11 p.m. till 6 a.m. for like 3 or 4 months straight, which can almost get to you if you're not too careful about it. Yeah, and other than that, I guess that's basically about aviation in Kenya, basically from my perspective. And hopefully the young guys can try and come join us. We see how we can get more airports, as many as possible in Kenya, and make air travel as cheap as possible. Thank you. Laura, back to you.
Thank you very much, Engineer Mulitia. So everyone, at least you know, if the cost of airfare is very tasking on your pocket, you know who to complain to. Is that guy who's just come from site. Thank you very much. And from my end, even I'm seeing the chats that are coming in. There are a lot of people who are very excited about airport engineering, Engineer Dennis. So you will have to talk to some people after this, right? Yeah, so let's move on. I don't want to waste a bit of time. Yeah. Yes. Please kindly mute. There we go. So next, we have a good friend of mine. I was in high school with him, Strathmore, for the last year. And then he studied civil engineering in the University of Nairobi. And he's one of the first few people who I know who went to, I don't know what it was, Tokyo or Japan or something, just to do geotechnical engineering for his master's. So ladies and gentlemen, Mr. Engineer Okari, are you around, or you going to play with the rocks?
Hello.
Hello, Engineer. Karibu sana.
Thank you very much, Engineer.
Alvara. This guy is I hope I'm not a new face to most of them. Now, yeah, I am Hesbon Okari. I practice mostly geotechnical engineering and trying to see which ways. I'm on my phone because I've been trying to connect this to this meeting on my computer, but I have not been able to for some reason. So now I will engage and probably present my slides from the phone. I hope it will still be okay. I'm from site and all along I've been.
It will be okay. Sorry to stop you. It will be okay. And if you won't be able to present, I think you'll just still send to me, and I'll make sure that the students get it. Yeah.
All right. Anyway, yeah. So I have been this is about my 8th year in engineering, civil engineering, but I branched off into geotech at the time, and it happened that most of my assignments since after graduation, I've found a lot of a field that is okay. Essentially, in Kenya, it's growing, and it is also the guys who have chosen to like specialize in it are not many. I would, by specialization, I would mean at least some postgraduate training. The undergraduate degree is good, but maybe as most of other presenters have observed, there's something to gain by you having either an undergraduate or a master's degree in these fields, in all of these subfields, I believe. So on geotech, there is in the university, you do about probably 3 or 4 courses in geotech. You're introduced to testing. I think it's one of those courses or one of those areas that there's a lot of testing involved. You talk about the lab tests you do on soil, and our 2 materials, actually, let me say the 2 materials, or maybe 3, somebody else is going to talk about the 3rd one, is a rock, soil, and then now there's the geosynthetics. We also count them as part of geotech, and someone else will talk about them. Rock and soil, they have a lot of tests that we do. And I would say that there is in Kenya currently, there's a bit of abuse of these tests. Abuse in the sense that we cannot get guys who can critique a test. You know, we take them to labs, they bring you results, but somebody cannot even say which, so long as they just told you the C and Phi, you are good and you think that is the right thing to do. But there's a lot more to soil behavior than simply the C and Phi. That's strength parameters, the grading, and the challenge for those guys who are starting to practice or were practicing as well is that how often do you link all those tests to like characterize your soil? Will you simply, because I know maybe most of the design softwares we're using, they'll simply ask you for the C and Phi, and then maybe the bulk unit weight of the soil, and you'll input those parameters, and then hey, voila, either it was a footing you're designing or something else. You simply be comfortable that you have captured, you know, the soil strength as it should be. Now, when you specialize a little bit in this geotech, then you get to learn that soil has a behavior. Soil tends to you know, it's not like concrete or steel that have those particular, you know, if you have a strength for steel or concrete, you are sure that it will almost always behave in a same way. In this case, in soil, you find soil that has, the grading curves are numerous. Rarely will you find 2 sites with the same grading curves for the soils and all, or even if you get soil that has the same strength parameters, then on account of the grading, you might find something that is at variance. So there is a need for us to understand soils more. There's a need for us to understand rocks even more, because we've reached a point where the reason Kenya has survived so far is that we have good grounds. And generally, the buildings, the tall structures we have in Nairobi are all sitting on sand, on rock. But if you look at the London, for instance, as a city, sitting on clay. Those guys have had to study it a lot more, study that soil a lot more, because you can imagine doing a skyscraper on London clay, and you'd imagine that, oh, maybe a deep foundation piles will solve this problem. But even that clay can refuse to work with the piles the way you've designed it, the way you've put it in your CAD, you modeled in your CAD. You might find there are other factors at play. Recently, I saw on Twitter it's Norway, and there was a phenomenon which we call quick clay. That clay basically, with a little bit of shaking, it becomes liquid. Out of nowhere, it becomes liquid, and then the houses simply slid all the way into the Atlantic Ocean or something like this. And what was previously, probably 5 minutes earlier, hard ground that you could walk on, turned into liquid. So all these issues, they come up in geotech. There is need, but I would say it supports structures, it supports roads, we support water, we support transportation. We are like that, it's the foundation, literally, it's the foundation for all these structures. We rarely, is there a structure that is entirely geotechnical? Not really. Talk of tunnels. For me, tunnels are geostructural designs, geostructural tunnels. There's a lot of interaction between the soil, the ground and rock, and the structural design, whatever, the concrete that you're going to have. If you talk about the road, the subgrade, the material investigations, there's a bit of there's geotech in that. If you talk about dams, it's a hydraulic structure, but there's a lot of geotech in it. First, the slope stability. You have earth-filled dams, you have rock-filled dams, and what makes them not fail? What makes those slopes not fail? There's a design. So you've done slope stability designs as part of your courses. So it helps to know that you'll actually use this in real practice. Apart from, again, sticking on dams, there's a very big contribution of geotech on foundation treatment. So as we say, not all sites are different. And the beauty of geotech is that rarely will you find yourself having to, replicate results from another site. Each site has to have its own investigations. So you have to travel widely. You'll travel widely to get these, to investigate the ground. You will also have to, apart from traveling, yes, you'll have to characterize each ground on its own, bearing in mind what structure you're going to build. If you talk about dams, as I said, apart from simply assessing whether that ground is strong enough or in terms of bearing capacity to hold that foundation, there's the aspect of permeability. Is this ground going to hold the water? Because you can build the dam wall above ground, but all the water leaks below. So we do some things, most grounds we find that we have to do, because of they are a bit permeable, we have to do what we call ground improvement, a procedure which is called grouting. And there are very many types of grouting. You have jet grouting, compaction grouting, permeation grouting, all this depending on the soils that you have. So it's actually a design as you go. And there's a lot of observational approach. It's not something that you can sit and design and then let it work. You'll go sample some soil and say this is clay. And ordinarily you say in clay we do jet grouting. And then you'll specify some spacing for the drilling of the holes. But for you to be sure it has worked, you have to be there during the implementation to actually adjust. Maybe you said that you need 3 or 5 MPa pressures to grout this ground, but when you get there, you find that the 5 MPa does not do much. So there's a lot of observational approach, design as you go in geotech. So apart from grouting, we have general ground improvement for areas that, and not necessarily dams, but even buildings. And this is coming to happen in Nairobi, a situation where all the good ground is now like built up or constructed. So you reached a point where you are left with riparian. Okay, maybe riparian is not, I know the water engineers will not like it when I say that we might have to be building now in the riparian zones, but swampy, probably yes, swampy areas where the soils are, don't have good, they're not the predictable type. It is clay, it is saturated. Then how do you build on this? You might find that for you to do a good building on that area, you will have to improve that soil. For a long time, there's been the approach of, if it is black cotton, simply excavate it and dump elsewhere. But where we've reached in Nairobi now, whatever is left is the place where they were dumping that black cotton. So you'll have 15 or 20 meters deep of black cotton, and you want to put up an estate. Will you tell them to excavate all that? What are the solutions to this? So it has to follow some, you have to do some decisions. They'll call you as the geotechnical engineer to advise. And actually what I'm seeing is we have reached a point where structural engineers, for a while, even in school, some people are telling us, oh, you're building on the red silt clays of, coffee, we call them red coffee soils. That one bearing capacity 100 kPa, 100. And then you do your footing, 150, you're good to go. And you can see that assumption now, guys have started using it on 10-story buildings. Maybe it worked for, it worked for a maisonette, okay? Guys are using it to do a 5-story. The worker cases, the houses are developing cracks all over in areas around Nairobi. Mm-hmm. It has reached a point where it is important for any developer or even a structural engineer to insist on having geotechnical investigations for a site. Mm-hmm. So that the exact or near, it's not an exact, it's actually an approximation, so that a proper approximation of that bearing capacity is arrived at, rather than the assumption that you are taking. So let me see if I can share my slide. Oh, sorry. What are let me go back to Zoom and try to share. Lula, can you put me to share my screen? Is that what were you doing? How are you doing that?
I think I can. I just click here. Just try sharing if you can.
Share my.
Because it will give you an option of which screen you want to share.
Okay, this one is not, it's bringing share document.
Share screen.
Yeah, no, there's no share screen. So probably I will add
it's okay.
prepare some slides.
You'll share to me. Yes.
Yeah, then you can. But what I had intended to, now that I'm looking at them, I would actually run through what I consider to be the issue, mostly geotechnical areas. Site investigations is one of them. Ground improvement is another. So we've agreed ground improvement can include the compaction, stabilization, dredging, all this stabilization. These are areas of ground improvement. They need designs. You don't simply say we'll stabilize. It's a design. Compaction, it's a design. So you can actually practice all this. Foundations for tall buildings and all buildings, generally bridges. And also there's another area which we call deep excavations, that as we go into doing tall buildings, they need basements, some 3, some 4, 4-story basements, and you need to design those excavations. Sometimes you find good ground where it's all rock, but also don't assume when you find rock, don't imagine that rock will necessarily self-support. Even rock, you might need to actually design for some rock bolting or support, or what do you call it, shotcreting of rock surfaces that have been excavated. Soils are even more critical. So you can't find an excavation of more than 2 meters in soil that can be self-supporting. So it's important that you either give it a slant, a slope that makes it, self-supporting, or if there's no room for you to give it a slope, a slanting slope, then there are measures that can be done to, sheet pile walling, retaining walls. This kind of temporary structures can help you to retain the soil and give you space to work. So retaining walls are also essentially geotechnical structural, the dams and tunnels as well. These are also there's a heavy geotechnical involved. In fact, you'll find that most companies, they are companies that are essentially geotechnical. Hayward Baker in the US, it's a big company. I think in contracting, it's probably, they say the top 500 contractors, and they are essentially geotechnical. You'll not find them doing skyscrapers, you'll not find them doing roadworks. Call Hayward Baker for your grouting, call Hayward Baker for piling, geotechnical works only. And they're big. And so you can actually earn a living as an engineer simply as a geotech guy. You're civil, but simply geotech, and you can make it. So think about the Nyali Bridge, for those who've been to Mombasa, those who've been to wherever, Kilifi, those sides. How do you think the foundations for that bridge were done? There's this middle pier. How do you think it was done? So essentially, those are what I will consider geotech. There is what you learn in school, again, separate. Soil mechanics is just a branch of applied science that deals with the study of physical properties of soil. It is the geotechnical that now applies the soil mechanics. So go beyond the soil mechanics and apply geotech. You will necessarily, most of the time, as we said, you'll be in the field and the construction site. You'll use a lot of laboratory testing, and then those results will be used in the design office to give you output. With that, I think I have more or less covered the area of geotech. Pros and cons. Well, I'll pick from what the other presenters have said. There's a lot of traveling. In one time, when we're doing some water projects in the coast, I think I traveled. I covered the coast area in some 6 months time, doing site investigations and all this, all the way from I think Tana all to Kwale, somewhere down there. There are about 6 water projects that required, this kind of input. A lot of traveling. There is a lot of field work as opposed to office. But I would say, is it easy? Well, softwares are there. We can model, but you have to use intuition, is all I can say. There's a lot of, yes, the softwares can give you, geotech is not an area where you want to be sure that you've given the software the inputs and it will not ordinarily give you the right outputs. You actually have to question the model. You have to be able to vary some inputs and see how the software behaves to be able to understand what the software is trying to do for you. Otherwise, you'll have modeled the wrong thing in the software, especially when we talk about designing tunneling, which is which is a lot of soils and rocks behavior. When we talk about deep excavation and also tunneling, those ones, there is a lot of geotech that requires more than just input, output, garbage in, garbage out for the softwares. Well, that might be notable failures. Most dam failures are attributable to not hydrology. Somebody will find they modeled the floods very well. Most dam failures, of course, the overtopping has an element of hydrology, but most of them you find it is the foundations. You end up missing something about the foundations. The recent ones, especially there is Solai. I think whatever was an issue around there was geotech, I suppose, because there was some piping. Yeah, it was geotech. There was a dam failure in Brazil. It was a tailings dam that attributable to geotech. There was in the US, even as late as last month, two dams failed, and from the failure, you could probably see the embankment was getting undermined and so on and so forth. So it also means that there's a lot at risk. Just one dam failing, you wash away a city. And you can, there's a lot of there are many documentaries online, you can see the effects of dam failures. Somebody said that a building fails and you have these many lives lost. Now imagine a dam failing that has a dam like Ndakaini, the whole of Thika will be gone, not a single building, the whole of Thika. And people will it will fail at night and people are sleeping. I mean, look at Solai, a very small, I would consider that a water pan actually. The Solai thing was close to a water pan, but 50 lives were lost and people were sleeping. These failures never happen during the day. So something for them to think about, and I would welcome them to pursue this area. That is all from me for now.
Thank you so much, Mr. Geotech Engineer. You've changed a lot ever since high school. This is not you.
I don't know what to attribute it to. Thank you.
No. You became wiser, as I can see. So, asante sana. As we rush, we have one presenter, Nyakundi. I don't know whether you're here. Are you here with us?
Yes, I am here.
Yeah, Karibu. This is Nyakundi. He can tell us something small about geotextiles.
Yeah. Let me place the camera correctly. Okay, welcome. Let me try to share my screen. Okay. I think you can see something on the screen.
Yes, you can. Thank you very much.
Okay, well. Here we are. My name is Nyakundi Henry. I think I might be the youngest presenter today. So I did a BSc in civil engineering from Dedan Kimathi University. I'm currently doing an MSc in project management. So I was in Bundi Associates Consulting Engineers, where I did water, irrigation, and sanitation. Then now I'm at Synergetic Energy Partners. I think there's someone else who has their mic on. I don't know if they can switch it off.
I'm trying to see that. Hezbon.
Yeah. So
I think he's muted. Go on.
Okay. So currently I'm doing geosynthetics. So geosynthetics is they are polymeric materials, which we use as inclusions to improve the the shear strength properties of soil. So as Mr. Okari mentioned earlier, he mentioned something about shear strength. So we have to improve the shear strength of soils and the tensile properties of materials in such a way that we are able to support road pavements. We are able to reinforce slopes. You saw what happened with recently when there is a slope that failed, and there was a huge pipe. which was exposed. I think it was Karemenu Dam, somewhere near Karemenu. I think there was.
I'm not quite sure.
Yeah, there were, yeah. So Sasumo, yeah, there was a slope which failed when the shear strength of the soil was not able to sustain the embankment. So geosynthetics can be of many types, and they can be used for various applications. So this area of geosynthetics is a very wide area. These materials are very diverse. You can apply them in water engineering, you can apply them in roads, you can apply them in geotechnical. So depending on the field of civil engineering where you are, you'll definitely find one or two uses for geosynthetics. So we can apply the geosynthetics in reinforcement. So here we use the tensile properties of geosynthetic materials to resist stresses. We can use geosynthetic materials in separation. For example, for when you're doing roads and you have a soft subgrade, and then now you have a subbase. You don't want the materials migrating into the other layer. So you put, for example, you can put a geotextile to act as a separation layer. So of course, definitely there are calculations there to determine the strength of the geotextile with reference to the loads which are coming from the traffic. So we can still use geosynthetic materials for filtration. I'm sure most of you know about the French drains. You can use a geotextile for drainage and filtration, where you prevent material from migrating from inside an embankment to outside. Just let the water flow by, but the material is retained inside. So this, of course, can be also be very useful for those ones who are doing dams. When we are doing the horizontal and vertical filters, you can be able to prevent the piping of material. We just allow the water to pass through, but the material is retained. We can use them as barriers. So for example, when we are at shorelines, we can have these huge permeable pipes where we pump a lot of sludge inside. Then, we use that one as a barrier. So moving on with for reinforcement, as I explained. So for reinforcement, we try to get, there's the action between the soil and the geosynthetic that allows you to carry out the reinforcement. Because of time, I won't be able to explain much. I think I'll jump right into the types of geosynthetics, the ones which we have. So we have geogrids, we have geotextiles, we have geomembranes, geosynthetic clay liners, geonets, geopipes, geocells, erosion control mats, geocomposites, geofibers, and geoforms. So for geogrids are, they're something like you can see on your screen. So these ones, they can be uniaxial, or they can be biaxial, or they can be triaxial. All that depends on the strength in the different directions of the geogrid. So these ones are mainly used for reinforcement. So for instance, in road pavements, you can use them to reinforce road layers, for example, the subbase. You can use them to reinforce the asphalt finished layer because they have good tensile properties. They prevent the formation of cracks, the same way you use fiberglass as an inclusion in road pavements. Also, you can use them in reinforced soil slopes. So if you have a reinforced soil slope that you are trying to do, you have a slope that is failing, due to an earthquake, you have problems such as a soil which has very weak shear strength, and you're trying to improve the stability of that slope, you can use geogrid as an inclusion in that slope to improve the properties of that slope. I'll show you an example later on. So we have geotextiles. This one more or less is mostly used for both reinforcement and separation. For example, you can use it in a geosynthetic reinforced soil bridge abutment. So instead of using a bridge abutment, which is made of concrete, you can decide to use a geotextile, and then you you construct in layers, continuously in layers, so that because geotextiles, they resist deformations. So they transfer the deformations over a wider area. So compared to the weight of the concrete is very heavy. you can use geotextiles over a wider soil, reinforced soil foundation to use them as reinforced soil foundation and abutments for bridges. Also, you can use them for embankments, road embankments. Imagine you have a situation where you have a very small right of way, but it's very steep. So you can use these geotextiles and geogrid combination to make an embankment in such a way that you contain the soil within a short distance so that you can be able to build on top of that. Then we have geomembranes. These ones have very low hydraulic conductivity. So the main job of these ones is to prevent liquids from flowing from one point to another. So for example, if you are making a pond and you don't want any water to seep away from that pond, for example, you're also making, let's say, a field, you're doing, let's say you have a hazardous liquid, which is dangerous to the environment, and you don't want it contaminating the immediate soil. So putting a geomembrane as the lining to your pond before putting the liquid will ensure that the liquid does not flow to the external surrounding. Then we have the geosynthetic clay liner. So this one also serves almost the same purpose as the geomembrane. The only difference is the geosynthetic clay liner is the material which is used to make it. So it is made out of some type of clay, and it is hydrophilic. So when it absorbs water, it has a very high permeability. So a very low permeability, sorry. So it won't allow water to migrate from one point to another. So this one can be used in conjunction with, let's say, compacted clay in landfills. So let's say you have a landfill and where you want to dump your material for this solid waste. So you can use the geosynthetic clay liner in conjunction with the compacted clay, in conjunction with a geomembrane, so that you can effectively contain the material and any liquid the leachate which comes from the landfill, you can direct it to an appropriate place so that it does not contaminate the environment. So as you can see, these materials, they are used interchangeably and together depending on how creative you are. So the problem will prompt the type of material that you're going to select to use in your design. So we have GeoNet. So this one is used for planar drainage. Let's say you just have a slope where you want to drain water from. You can just wrap it with a geotextile, then you put it in between there. So when the water is flowing from top to bottom, it is intercepted by the GeoNet and it flows out. So that one isn't much of a big deal. GeoPipe, just normal plastic pipe which you see around, maybe PVC, maybe HDPE, maybe PPR. So any variations of those pipes are geopipes because they are made from plastics. So any pipe you see around, so the geopipe is something which you see often. So that one. So we have the geocell. So the geocell, it can be used on slopes. It can also be used in roads. It is used for containment. So when a vehicle is traveling on a road pavement, it exerts a load, an axial load on the road pavement, which in turn deforms horizontally. So there's a lateral deformation. So, and with time, you find that on that road pavement, the material is chipped off away from the road sides. So this geocell ensures that that material is contained within its cells. So you find, I'll show you a picture later on where you will see it more clearly. It contains the soil within the cells so that because it has tensile properties, and the vehicle travels, exerts the load, it expands, then it comes back. We have erosion control geomat. So this one is just for erosion control. Basically, you just put it on top of a slope which you have excavated. Then it ensures that vegetation grows back a bit faster. So it isn't much of a big deal. Then we have a geocomposite. A geocomposite is basically any two geosynthetics which you have combined together so that you can be able to achieve a certain objective. For example, if you want to use a geosynthetic for drainage, but you don't want soil to get into that geosynthetic, for example. So you put a geotextile around that drainage. So you have used two geosynthetics together to achieve a certain purpose. So that is a geocomposite. So for example, you can see here, you can combine a geogrid and a geotextile. can combine iron and an unwoven geotextile, like that. You can combine a geopipe, like a pipe, just a normal PVC pipe or HDP pipe. And then maybe you are using it to drain water from beneath, let's say, a retaining wall, but you wrap it around with a geotextile so that soil does not get into the pipe to hinder the drainage properties. So for practical applications, so currently you can see here, what you see there is a geogrid. So this one is being used as we speak. We are using it to build a parking lot. So we are putting this geogrid in layers. So you have to understand a lot of soil mechanics and geotechnical, as Mr. Okari said. So you have to understand the properties of the soil which you are dealing with. Then you have to understand maybe the traffic loads which you want to use it for and the application. So for example, here we are dealing with very huge trucks. So based on the calculations and the type of soil we have determined the strength of the geogrid which we want to use and the spacing between one layer and the next. So this one is in a parking lot. So this also can be used on roads. So depending on how creative you can be. Then this other one, this is you can see this one here. This one is a geotextile, the white one. It's an unwoven geotextile. It is being used for drainage. So it's like sort of a French drain. Inside here, you will find aggregate, so that when you cover this one with soil, water can travel laterally along this geotextile and the aggregate to the face of the slope. The one you're seeing beneath is a geogrid. So this one is a reinforced soil project. We are trying to protect a slope, which is prone to sliding. There's a surface erosion here. This one is a geocell. This one here you're seeing is a geocell. You can see we have apertures. There are several apertures here on this geocell. So this is where you put the fill. You put the fill inside these apertures. So for example, this one, the depth of the apertures is the depth of the geocell is about 200 millimeters. So when you put the material here, you join these geocells together. They just come, as small units. So you join them together. You put the material inside these geocells, and then you compact as usual. So when a load is applied on top of this one, this geocell is very flexible, as you can see. If you look at it, it will expand, and then when the load goes away, it will come back to its original shape. This one here is a reinforced soil slope. So this place had a lot of erosion problems. So using reinforced fill and geogrids as reinforcement, you can be able to prevent the erosion on the surface of this one. And also in the process, we will allow for vegetation to grow on top of now this reconstructed slope. So the one you're seeing in the middle is just a drain to allow water to move from the top to the bottom of the slope. I think that's it. These materials, I would like to say that this area is very wide. It's not like an area you can say the applications are so wide, just depends on your imagination. So depending on the field of engineering where you are, if you're in foundation engineering, roadway, water engineering, structural. So depending on the field where you are, when you find a problem, when you know that there is a material that you can use as a substitute, you can be able to effectively use geosynthetics in your day-to-day designs. I think that's it.
Thank you very much, Nyakundi. I like your vavum in the group even. You're the one who came to me personally and said, I want to say something about geotextiles. And I gave you an opportunity and you have not let us down. So thank you very much. I have learned a lot, basically, from you. And tuendelee hivyo. Now, I know you are supposed to be the last one, but someone has just reached out to me privately and said he wants to say something very small about water and sanitation, because the presentation on water that was done by Kyunga was on hydrology. Yes. Now we have a gentleman by the name Mali Musilu. Mali, can you hear me?
Hi.
Hi.
It's not a gentleman, it's a lady.
It's not a gentleman.
No.
I'm so sorry.
You're forgiven.
Oh, I am so sorry. But I am sure whatever you will say, it will impact us.
Okay. I hope so. I really hope so.
Yeah.
Okay, so I think I'll start with my name. I hope everyone can see me and hear me clearly.
Mm.
My name is Mali Musilu. I am a civil engineer, and since my graduation back in 2014, I have been in the water and sewerage department of our company. Actually, Kiunga is my colleague on site currently. So we are just from site together.
Okay.
Yeah, so I just want to say 1, 2, 3 things about water and sanitation, because it's a field that I've been interested in ever since I was in school. And I will start with water supply and distribution. So we essentially, what we do in water and sanitation is supply water to customers, and then now get that water back in the other part of sewerage. Now, what one lecturer of ours used to call shit engineering. So yes, I'll start with the water side because it's more likable and less off-putting. So I think for water, we normally do intake structures. This will be either a weir or a dam, or essentially, or a small intakes, offtakes from the river, if it's a river that we are dealing with. And from there now we have a treatment plant where we treat this water to a level where everyone can now drink. The level is mostly, the standards we use are the World Health Organization standards to know if this water is healthy, is good and healthy for and safe for people to take in. So after treatment, essentially every I would say design, most part in engineering you would provide for storage because of our country is not very, it's not very wet. So most parts you'll find they are dry. We have dry seasons and wet seasons. So we need to store our water from the extra water that we have during the wet season, so it can be used during the dry season. So we provide like at least a half a day storage, just in case there's a breakdown also in the system, so that people don't suffer downstream. So we'll have our storage tanks, and then after that, the water, according to design, is supposed to get there to the customer at least 10 meters pressure if it's possible. This is when you're using a gravity system, which I personally would recommend to any client because maintenance costs are very low when the water is just naturally flowing to the customers. And most, I would say, from this water aspect generally, because this was very impromptu, I've not prepared any slides, but I say our clients are the initial water boards, who are currently the water works development agencies. So in Kenya, we have about 7 or 8 of them. I think I'll confirm that later. But here in Nairobi, we have ACEK Water, who then, and then we have the WSPs. I'm sure the students have done that in their course line underwater. So we will have the WSPs, who are I would say maintaining the beneficiaries of the water. So they are left with the project to maintain, to charge tariffs to their customers. So they are like more of what will I call it? Agencies that collect the income. Yes. So then that is essentially what we'll have in water. After your storage tanks, then you can distribute your water to now the beneficiaries. This depends on demand, which is calculated directly from population projections. And our design is majorly 20 years, to cater for 20 years of supply. So it depends with the client preferences as well. So I would say the manual that we use for water from the Ministry of Water recommends the 20 years as the minimum design period. Now, after that, now, when you supply water, of course, people will have wastewater coming out. So, in design, this wastewater is about 80% of what you supply. So, essentially, we use a sewerage generation factor of 0.8. So what that means is if you're supplying water, then 80% of this water is produced as wastewater. So I would say in our towns here in Kenya, we have a big problem of wastewater management. And I think personally, that is a field that I'm very, very, very focused on as a professional. And I'll explain just a bit about the design of sewerage systems. We can have aerobic and anaerobic treatment plants for sewer, and the conventional ones that are used by our government are majorly the anaerobic ones, like the ponds we have at Ruai, where it's just a natural kind of treatment of water. And then now the mechanized ones that people use for, we have one that is mechanized and working well at Two Rivers. I think the students or any engineers that would be interested to see how that works, they can visit that site. Yeah, so I guess currently, personally, we are working on a sewerage project for Kiambu and Ruaka. We have a bit of Kiambu having kidogo sewer coverage, but then that was done a while ago, and so there's need for expansion. So that's what we are doing now. So I'll say sewer lines are more what you need to look at when you're designing sewer lines. It depends again with the amount of water, wastewater that is generated. So then you'll size your pipelines according to that demand. Of course, the QVA again. And then now for sewer lines, the major, most important thing to look at is the inverts and the slopes, so that you ensure gravity flow. Sometimes we prefer not to pump sewage because of the factors that most of our sewer is not pre-treated before it's released into the sewer system. So you'll find if you're pumping, then the pumps are having blockages every now and then. So most designers prefer going towards having a gravity system to a treatment plant where you can choose now to use the mechanized or just the conventional bacterial treatment process. So yeah, I think in essence, that's what I would say about water and sanitation, and the feeling of just helping people cleaning the environment. If you're very passionate about the environment, then this is the field for you, and you'll see change even as you progress in the field, whether in design or in supervision. And you'll see as years go by, you see your work actually bringing a difference into the community. So I guess in conclusion, because I've been given a very short time to present, I'll say that's all from me, and I hope people choose this field because we need more and more people coming into water and sanitation.
Mm.
Yes.
Thank you very much, Mali. Definitely, you're speaking in the next one. Definitely.
Thank you. Thank you so much.
You'll just maintain that the presentation, and in the next one you will speak.
No problem. Wow. I'll gladly do that. Thank you.
Okay, sawa.
All right.
It's been 2 hours. 2 hours. We are finally done with the presentations, and we want to now allow for questions from the UON students. And I don't want it to be very haywire. So I think we would allow for about 3 or 4 questions, but if you would like to say something, you can just reach out to me via chat or raise your hand, because once everyone unmutes the mic, it will be a lot of chaos. So we are ready for questions. Oh yeah, and we can also take questions from the participants of future leaders who are here, because a lot of us have learned a lot of things because we were all just focusing on our own subfield, but we've realized out there it's very interesting. So we're also taking questions from participants from future leaders. And your engineers, do not fear. I'm not seeing anyone asking anything. So Alfred Obadia has raised his hand. Alfred, kindly unmute your mic and ask the question.
So I have a question concerning research. Now, mainly what we learn in school and what we practice as a country is based on what other people have done. And I know it takes a lot of effort and resources to do research, but is there research going on? Are there research opportunities going on in all these fields that have been presented about today?
All right, I think I'll answer first according to what I know first, and then I'll open the floor to my fellow hosts, the guys who presented. I think they can say something. So what I'll say is, yes, I do believe there's a lot of research opportunities, especially like, this is someone like me, I did my civil engineering in Jomo Kenyatta University of Agriculture and Technology. And we all know that that university is research intensive, not only in civil engineering, but in, a lot of agricultural studies actually go on there. But if I'm to speak civil engineering specific, we partner with the Japanese a lot, and that's how we do all our research. So for instance, we had ICAD. If there's a JQuad person here, he can tell us that ICAD, it was a partnership between the Japanese and us guys to basically improve on, let's say, like the materials that we use and our craft and what we do basically in the civil engineering field. So if you look, you can find where they're doing research. Yeah. So for instance, the JQuat, I am sure UON have their own research programs. Yeah. So it's a field that you can't just get out there as of consultancy. You probably have to go to higher institutions of learning so that you get what you're basically looking for. Now, I don't know if anyone else has something to add, especially the hosts, in terms of research.
Maybe I can add something.
Mm-hmm.
Yeah, I think on the field of research, the universities are doing something, but I believe there's a lot yet to be done.
Mm-hmm.
I think from where Alfred is coming from, many of our standards have been adopted from the other nations. So they you might find some of them may not be applicable, or the factors of safety and the factors included in it lead to, at times, increased costs and something like that. So it will be good to also have research done within our country. talking of the, the design manuals, if you look at them, and even considering other nations, if India has their own standards, you can adopt aspects from other manuals, but essentially it's good to have that research background from people within your country who have that local expertise and local knowledge, and they're able to transfer that into now, from their research, being able to transfer it to practical uses. So I believe there's a lot more that can be done in that area. Yeah. Then.
Hello.
Yes,
Hello.
Helbon, talk to us.
Yeah, I can answer that as well. We have, yes, there's research going on in the country, but I would say it is not coordinated. It is not, you do not know what the end product is supposed to be. Because if you look at it, the guys who do, essentially most research projects are master's studies and above. So you have a student, a master's student, especially at the university, you have a master's student who's working on a certain project. And it starts with, okay, in the country right now, you find that most master's students will approach a professor or a lecturer, and they'll be asked for topics, or which area do you want to study? Then a professor will tell you, oh, this area you need to talk with the Professor so-and-so, or this one, the other one. I would contrast this with the practice in the West, which is, or even in Asia, where you have multiple studies adding up to a single innovation, or what do you call it, innovation or a publication about a technology. And that means you have a professor who says, I'll study geosynthetics and how they perform in the local, with the soils in Kenya. And he'll have more than 6 master's students, maybe not in the same year, not in one go, but over 5, 6, 7 years. And at the end of it, a publication will come out that actually really applies, gives you a guideline on how to use this geosynthetics with local coffee, red coffee soils. But now around here, you'll find that, today this guy, the prof, is dealing with hydrology. Tomorrow he gets a student in transportation. Okay, not literally. I'm simply saying that there's some variance. There's no, it's not a research project. It is what is giving the student a master's degree to leave the university. And how can we get to a point where we have that dedicated research? If we talk about road safety, we have a guy who's dedicating his research efforts, a professor supervising research efforts in road safety. It is funding. From the recent budget that was read, I think last week, the National Research Foundation was given 327 million. That is to fund research in all areas in the country for the full year, in all fields of study, not just engineering, the whole talk sociology, biology. Yes. That when you have a 3 trillion budget and you're only putting 300 million in research, it tells you the importance you are giving to research as a country. What I meant to say ideally is that you find in other countries, the West, you can be a professor and that is like your whole life will be comfortable, because a simple project like that one of using geosynthetics and shooting it to local conditions and publishing this data, you'll get a grant of about 100 million equivalent, Kenya shillings equivalent, to actually do this project over a span of maybe 5 years. And this money goes into the materials. It also compensates the students, even the professors. And that way you get dedicated professors who are researching on issues. If you look at the geotechnical standards, even the Eurocodes, each country in Europe has an annex which has data, which has local data that can be applied to the principles enunciated in each standard. So here now we are talking about adopting Eurocodes, but there's not a single where deposit or database where you can find data that can be enough to make a national annex for Kenya.
Annex, okay.
So, yeah, so if we were serious about research, KEBS and whoever, you know, with the National Research Foundation of Kenya, NACOSTI, all these guys, they should be putting money into specific projects. So I have to say that we are a bit backward in research. So today you get a transportation student, you know, representing about use of footbridges, and then the same professor will pick another student who will study, subgrade, and then, you know, that project will end there. You'd imagine that maybe there will be a second or third student who will talk about footbridges, but on another level. So that at the end of, you know, 3, 4, 7 students, you have really a body of knowledge about use of footbridges. The subject itself is not bad, but there's not. So how can you use findings from one student to say that we have studied, you know, trends and how users use footbridges in Kenya from one student? No, so I feel that we have a long way to go. And even in the West, again, to put this point out is that geosynthetics were developed first, not even from the university. Companies, I would say that about a company in Taiwan that develops geosynthetics. They're called, I think, ACEK-Geosynthetics. This company, they were plastic manufacturers. They were doing paper bags, plastic stuff, and then the country banned use of plastics, the carrier bags and all. And the company reinvented itself by simply now funding university professors to actually find alternative uses for their plastics. And within 3-4 years, they had sample products. You know, they were now selling geogrids, they were selling the geomembranes, and they didn't have to close their factory. So around here, you know, we make profits, companies make profits, and they go and, you know, and so I have a feeling that we have a lot more to do in research. Thank you.
Okay. So for the individual who asked, oh, sorry, you had something else to add?
Yeah, just adding on top of what Hezbon has said.
Okay.
Yeah, actually, the products which we are using are actually from that geosynthetics from Taiwan.
Oh,
so,
okay,
yeah,
really?
Yeah. So the products we're using, even the guys who I'm working with, who are trying to train, who are working with the field of geosynthetics are from ACE. They're engineers from ACE. Yeah.
Oh, great.
So
great.
yeah. So yeah, actually they're really good. So what I was trying to say is that there's actually a lot of research work to be done, especially on the foundations, soils, everything and all. When you look at the manuals, I'm looking at the manuals for Federal Highway Administration from the United States, and they have mapped every single place in the United States with respect to type of soil which is found in a certain place, the probable consolidation or over consolidation pressures which are supposed to find there, if the soils are normally consolidated, over consolidated, pre-consolidated. I mean, the different conditions that you will find of even the rocks and the possible ranges of RQDs for those rocks in various places. So the research, it ensures, the research which has been done there ensures that the costs for doing, for example, geotechnical studies or building, they are slightly lower because you know exactly what you're going to look for. You know, this area has this type of soil and this soil has this range. So the type of equipment which is suited for compaction, type of equipment for the type of tests you're supposed to do are this range. So you see, so it gives an engineer an idea of what he's going to do there. So Kenya, I think we have a lot of areas that we need to do research in, but they need the goodwill of those ones who are in charge, the goodwill to give the funding and the support and the framework so that the research can be done in these areas. But the potential for research is there. The areas to be researched are very many and they are very wide. But now the government, the goodwill is now what we don't have So I can say of now. That's all.
Okay, thank you everyone for your input. And there's a message that has just come in that says,
there's a question. There's a question on the chat. Yeah, Mike is asking the difference between a transport planner, a transport economist, I believe, and an urban planner.
Oh, yeah, I've just seen that question. I just wanted us to finish with the one for research first.
Okay.
Yeah, so just to finalize on the one for research, I got a message that says ACEK-FL actually employs engineers in research, mainly in water and environmental sector. ACEK-FL is the forest guys, wild agroforestry, I think, or something. They are located near the UN, not wrong. They actually employ a lot of engineers in the research, mainly in water and environmental sector. So if you want to have a job at them, you can try. So now we can go to the next question that actually involves transportation engineers. And I think, Engineer Paul, you can take it. You can take it from there.
Yeah, I think someone's mic is on.
Yes, I'm trying to locate. Okay, go on, Paul.
Yeah, okay. So the transport economist will look at mostly the cost side of transportation. So they'll usually come in at the planning and design part to look at basically whatever has been designed or whatever is being planned, how much will it cost, and basically comparing that with evaluating that to look whether it's beneficial to the public. So they look at the cost of money, they look at even the cost of time, and also environmental impacts, and basically all these factors, they'll convert them into in the terms of in terms of money. They'll evaluate what is the cost of the time, what is the cost of those environmental impacts, and basically that's where I believe you've done the different calculations of net present value, internal rate of return, and cost benefit analysis. So that's where the transport economist will come in. Then the urban planner basically looks at urban regions and is mainly concerned about land use. I'd say land use and the built environment and the infrastructure that is within that area. So it's pretty large scale. It is above, I'd say it's more high level, looking at, because they're basically looking at the architecture, they're looking at the even communications, looking at the transportation network. So theirs will be an overall urban regional planning, whereas the transportation planner is now looking only at the aspects of transportation planning that pertains that region. So they won't focus a lot on the land use and everything. Those ones are inputs. The land use will be an input for the transportation planner to now be able to design a network or even offer solutions for whatever may be affecting the transportation network in an area. For example, the congestion and issues like that. So those are the three main differences. The economist looks at the cost side. The transportation planner is focused on the transport aspects of planning, and the urban planner now is focused on a high-level planning consisting of the transportation sector, the built environment, and other sectors such as water, communications, etc. Yeah.
Thank you very much, Paul. Now, as we draw towards the close, actually, I wanted a lady to ask a question. I don't know whether the civil engineering class has a lady to ask any question. Probably give them 30 seconds. From my screen, I can see someone called Mary Joy. I am not sure whether that's a future leader guy. So any ladies from the Civil 5 UN to ask a question? There's a chat that has come in from the group chat. A request that the presenters inform us on available job opportunities in their relevant companies. Thank you. Okay. How can I attack this? We're in the COVID era. Jobs are a bit scarce. We're just finalizing on jobs that we were working on before this COVID era, came upon us. But there's prospects for next year. Definitely, there's a lot of things that have stalled this year, and there's a lot of monies that have to be moved around. But as per next year, yes, I am a bit optimistic about all the development that is, going to take place. For instance, I'd even just talk about the expressway, the double-decker road. I think the workers is starting, if I'm not wrong. So if you're looking for an opportunity there, I don't know who the contractor is. Could be CRBC or China Oil, I'm not sure. You can source with them an opportunity of employment. So there's no lady to ask a question.
Aldura,
Okay.
there's a question for me.
Oh, there's a question for you. Okay.
Yeah, let me just read it out. That's from Mike Jomo. He's asking why I thought venturing into other fields would, okay, because we have seen there are so many fields in civil engineering. And my thoughts were that starting with structural engineering would be the best. And I say that is from my experience. It doesn't mean that if you start with roads, if you want to go back to structures, you couldn't. But most of the time, what I've seen, and maybe Engineer Kennedy and Mali Musilu, who are also my colleagues, would also agree with this, is that because structural engineering is mathematics and office-based at first. So a young engineer starting in the office would be a good thing because you're able to understand the structure of how business is run as opposed to just going to site directly. And then in the office, especially in an office where you have both structures, roads, and water, if you could practice, say, 3 years in structures and then talk to your seniors to take you to another field of civil engineering when you are young, that could be a good thing. Because say you practice transportation or water for 10 years and then you want to go back to structures, most people find it difficult. So this is just for those who want to be all-rounded. My opinion is that it's best if you start with structure maybe for a few years, then go into the other fields. which you probably will end up doing, and maybe do structures for your side hustles or something. So I don't know whether I've answered Jomo on the same. I think that's my side of the story.
I think you've answered it, and particularly where the point where you pointed out, it's easier to start with structural engineering so that you get a basis as you venture out there. You know, if you want to be an all-rounder in civil engineering, because what I found, especially in my career path, is with structural engineering, especially, you know, buildings, maisonettes, bungalows, low-rise, high-rise buildings, it's very easy to get a personal job. You know, these things that we call PJs, these things that put food in our table, that supplement our salaries. It's very easy for you to get a PJ. You can design something and have a professional engineer have a look at it, ratify it, and, you know, according to how he's satisfied, you can submit the drawing for approval. Yeah. So I kind of agree with Engineer Mtitu how you should actually start with structural engineering if you want to be an all-rounder. Also, Engineer Okari has said something to the tune of, later, you guys, the UN students, you're in campus still, but later when you finish, you can join ACEK Future Leaders after graduation, especially if you're in a ACEK member firm, where here we share opportunities as they come. We give advice on where to work, where to go, and we basically network. We don't leave any soldier behind, you know. So we all go in front. Now, you guys, I'm seeing a lot of questions coming in, and it's 6:37. Maybe if I can just address one, then we head over to Madam Chair to give us a vote of thanks or to say something. So Nicholas Achila has asked, do I need an MSc to pursue airport engineering? If so, which would be the best one? I'll answer, but much later. The guy Engineer Mulitia, who did the presentation on airport engineering, he had to step out, he had to go do some side duties. I think he will also answer much later and will be sure to make sure you get the answer. So in my opinion, I don't think you need any MSc to pursue airport engineering. By the time you're done with your BSc, I think you can, you know, jump from one subfield to another, as long as you're very quick in learning these things. For instance, what Engineer Mulitia said, there's not much difference between airport engineering and, let's say, highway engineering, especially on the taxiways, on the runways. It's all just a pavement structure. Maybe one is concrete, the other one is bituminous. It's all just a pavement structure that needs to be laid out, and the levels need to be very, very up top. The only difference is now the traffic that you're expecting. Of course, it's planes, and I would say the pavement is surrounded by other structures or other buildings that are very critical for the holistic performance of the whole airport. So it's something that you just need to dive into it, you know, in the deep end, learn the ropes from first principles, study your ICAO, study all the manuals of airports, and, you know, you'd do well actually. And also, just to finish with Nicholas's question, yes, there are master's opportunities out there for airport. In fact, I know of one in Loughborough University, which gives an MSc in airport planning and management, which is a one-year course. So yes, any university that offers transportation studies out there, you'll definitely get an MSc that has something to do with airport engineering. Yeah. So unless there's someone else who wants to add something, please, 20 seconds before I give Madam Chair to say something.
I think I'd like to just verify, because it's the part of choosing structural engineering before any other field of civil engineering. It all depends with how you get into the market first. So don't just go in thinking that you will go into, say, water and sanitation or something like that. The first job you get, mostly, they're the ones who are going to tell you what your job description is going to be, where you're going to land. So you might find yourself, you have to just be flexible. You might find yourself in structures, you might find yourself in roads, you might find yourself in sanitation roads and in water and sanitation. So that's essentially, that's it. So in terms of hearing, okay, there's a concern, or there's people seem to be a lot more interested in airport engineering. So I just want to sort of be the devil's advocate. When you're looking into a sector that you want to pursue, you also have to look in the long term. After you've done your 8 or 10 years in it, or how is the job market in that field? Are they actually employing more people? Because most cases you find into a job sector which is already saturated. Our sector is all about your number of years in terms of job, your experience. So you might find some people have stayed there for as long as, somebody could be 70, 80. They're still experts in that field. So you have to be cautious as to what field you want to go into, not just for the name or for the, on that front. Somebody also asking about water and sanitation, public health, sewerage systems that are government initiatives. So the state of the sector is primarily because the reason why the water, sanitation, and public health sector it's diverse. You have the NGOs who come into play. You have the government who are also there. So it's quite diverse. You just need to know what you're targeting. The clients are usually government because you'd find it's a public-private partnerships that and can be still government initiatives, but they rely so much on the private sector to just grow or to put in the infrastructure. So the sector is still okay. It's still good, and it's good to go into it. The only thing is probably the funding could be a challenge once in a while. Currently, we are working at Kiambu and Kiambu sewerage and Muranga water supply, and our client is Ati Water Services Board. So you find that sometimes you'll be partnering with government to do a lot of these projects, and they actually do offer competitive, I would say, experience in terms of what you'll be able to be doing. So the field is open. Whatever you get yourself into, do not discriminate. Do not side with anything. Just go ahead and do it. You will find your way through it. So don't be discouraged, and don't just side on one side. I don't know. Does it make sense? Do not just lean on one thing.
Don't lean on one side.
No.
Thank you so much, Kennedy Kiunga. Guys, the questions are many. There are many. I'm receiving all the chats, but unfortunately, we have to cut it, man. We've had so much fun, and we'll reply to everyone the questions. And if you have additional questions, you can also send them to the email address that was on the poster. Yeah. So if everyone is okay, I think I would like to invite Madam Chair, Engineer Una, to say something before we wrap it up. Yes, I can see you, Madam. Hold on, I'm trying to unmute you.
Okay. I was talking to myself for a while there. Yes, thank you so much, Alwara, for this very educative session. I've actually learned a lot. It's like from transport and airports and water. So many of my colleagues who are presenting right now tell me I'm inside doing a water project, and yeah, as a structural engineer, I look down upon them. They're doing important stuff. So it's good to know. It's good to know. Anyway, let me introduce myself. My name is Latoya, Engineer Latoya Ona. I'm a structural engineer first, BSc Civil Engineering, year 2011. I did my MSc in construction law from the University of Central Lancashire, the UK. I am a director and claims expert at Design Masters Studios Engineers and chair of ACEK Future Leaders. So thank you so much, civil class, for attending. We were all once there and we all went through the same challenges, and we hope that what we've told you will clear your mind a bit. It won't be 100%, but it gives you something to think about. Out here is what you make it. If you want it to be difficult, it will be difficult. If you want it to be easy, well, it won't be easy, it will just be easier. But it's actually your attitude and what you make it. Engineer Kiunga said that when you get out of here, have an open mind of what you can do and what you can achieve. And you will get there as long as you have a plan. So for me, the first job I had was in structural engineering, and I went through it for maybe around 6 years. Then I didn't want to do it anymore. That's when I took construction law, which is, it's okay. So I'll tell you a bit of ACEK. I don't know if Alu has introduced what ACEK Future Leaders are. We are a subgroup of the Association of Consulting Engineers of Kenya, who are basically our bosses. We are the youth wing, you could say. We are members of the FIDIC Future Leaders and FIDIC Africa Future Leaders. And I think I said in the chat that gives us opportunities to explore other areas and other countries and how they do the engineering in Africa and in the world. So those are some of the advantages of joining us. I don't need to say much. I think you've been told. I don't need to saturate you with more information. I will leave our Facebook links and our Twitter here and LinkedIn, where you can ask a bit more questions if you want. Also in the Gmail, which I found like two questions about employment opportunities. We do our best to scout for employment opportunities when they come by. There are a few right now, but they're there. And we hope that the construction sector will open up further in the coming days. So we'll keep you posted. Just keep in touch with us, and you never know what maybe you might land a job. I'm not assuring, it's just, luck, I think. What work opportunities are available for a civil engineer who does not want to work in civil engineering? The advantage of civil engineering is that you're very analytical because you have done mathematics from your first year to your fifth year. Before, when there was a problem with employing civil engineers, many of them went to the financial sector. Many of them went to banks. Many of them went to audits and accounting and all that. But now that area is saturated. But you can keep your mind open. You can go to IT. There's very many things that you can do. IT to support civil engineers. You can do financial to support financial engineering, to support civil engineers, PPP. There's so many other things that you can do. So just research on that. Don't think that the hardcore civil engineering is the only way if it's not what you would like to do. So those are the two questions I found on the email. And I will leave it at that. Thank you so much for attending. We hope to see you soon out there. And poleni sana, I'm sure you guys are graduating this year, and yeah, this happened. But yeah, we'll wait for you next year. Bado, it will happen. So thank you so much and have a good evening.
Thank you everyone for joining us. Until next time, because we'll definitely do this another time, especially with you guys. Traditionally, we are told that University of Nairobi students like striking a lot. But for this session, I don't think I've seen any strikes. So thank you very much. To the next one. Cheers.